So, let us see a simple example. A person has undertaken a job. The probability of completing the job on time if it rains is 0.44, and probability of completing the job on time if it does not rains is 0.95. Okay, if it rains it is 0.44 and if it does not rains it is 0.95. If the probability that it will rain is 0.45, see, it is given probability that it will rain is 0.45, then determine the probability that the job will be completed on time. Okay, let us take some simple variables here. Let R be an event that it rains, RC be an event that it does not rains. Okay, let C be an event that job is completed on time. We have to find out this C. We have to find out the C. What is P of R? That it will rain is 0.45, which is given in the question. Probability that it will rain is 0.45. Probability that it will not rain is 1 minus the probability it will rain, that is 0.55. Now, we are also given probability of completing an event. Probability of completing an event given that it rains. Probability of completing an event given that it does not rain is also given to us. See, we are given P of C by R, that is 0.44, and C by RC, that is 0.95. Right. Now, they are asking to find out the probability of C. What is the probability P of C? What is the probability of completing a job? Right. So, but that by using total law of probability, P of C is nothing but P of R into P of C by R plus P of RC into P of C by RC. This is the total law of probability. So, with this, if I substitute all the values, I get 0.7205. This is the probability of completing the event. I will just go back and see what is the question here. You are given probability of completing the job on time if it rains and also if it does not rains, and we are given probability that it rains 0.45. Determine the probability that the job will be completed on time. So, we were supposed to find out P of C from the given data. So, we applied total law of probability and we found out that the solution of that, right, 0.7205. Okay, let us see now another problem on Bayes theorem, right. So, interesting problem. In a factory that produces bolts, there are 3 machines A, B, C, and A manufactures 25%, B manufactures 35% and C manufactures 40% of total bolts. Now, among this production, among this manufacturing, right, there are some defects in each machine and they differ. The defects in machine A is 5%, defects in machine B is 4% and the number of defects produced by machine C is 2%. Okay. So, every machine has their own defective bolts they are manufacturing. A bolt is randomly selected from the overall production, means from the 100, okay, from whatever is given to us, right. It is found to be defective and it was found to be defective. What is the probability that the defective bolt was produced from machine B? Out of 100, I am randomly drawing 1. What is the chances that it is defective and it is from B? It is defective and it is from B. This is the question what we have here. Okay. So, there are 3 different machines A, B, C, and they are producing manufacturing bolts. A produces 25%, B 35% and C 40% of the total number of bolts. Out of that, the performance of the machines differ. So, machine A produces 5% defective bolts, machine B produces 4% and C produces 2%. A bolt is randomly selected. What is from the overall production, what is the probability that it is from B and it is also defective, right. So, how do we solve this? Let us see. So, total bolts manufactured by A is 25, by B is 35 and by C is 40. Now, if you convert into probability, so P of A is nothing but 0.25, P of B is 0.35 and P of C is 0.40. In that, we are also given that A produces defective bolts, all 3 A, B, C produces defective bolts. So, probability that we get a defective from A is how much? 5%, so 0.05. Probability that we get a defective bolt from B is nothing but 4%, that is 0.04, and same from C it is 0.02. This is the data given to us. Now, we are supposed to find out that when I randomly draw a bolt, it should be, and it is found to be defective, and that defective is from event B or machine B. So, what we try to do here, we apply Bayes theorem here, we know P of A by B is equal to P of B by A into P of A by P of B. So, we have to find out probability that it is from event B. So, how do you find out from B, right? See here, so we want to find out a bolt that it is defective from machine B, we want to find out this P of D by B. See, a bolt to be defective, we know this value already. What is the defective, what is the probability of a defective bolt from machine B? We are supposed to find out, given that the bolt is defective, it is from B, we have to find out this P of B by D, right. Given that the bolt is defective, what is the probability that it is from machine B? So, for that I apply the total law of probability also here. So, we know what is the formula of P of B, it is nothing but P of B into P of D by B divided by P of D. But how do you find out P of D here? How do you find out P of D? So, to find out P of D, we apply total law of probability. What is the formula for P of D? It is nothing but P of A into P of D by A plus P of B into P of D by B plus P of C into P of D by C. We know all these values. Substitute that, you get the value as 28 by 69. Okay. So, this is the Bayes theorem formula. We are supposed to find out, given that it is a defective bolt, what is the probability that it is from machine B. So, I am applying Bayes theorem. I know P of B by D is nothing but P of B into P of D by B by P of D. But what is P of D? We do not know that. So, we apply total law of probability here. P of D is nothing but P of D is nothing but P of A, that is what the event, whatever event is there, P of A into P of D by A. So, this could be anything, it could be A, I if I put, depending on the number of machines, number of defective machines, then we apply this. So, by applying the law of probability, we find out P of D and we substitute in the Bayes theorem formula. So, we get the value as 28 by 69. So, the probability of getting a defective bolt from machine B, if you are drawing one randomly, is 28 by 69, right. So, this is Bayes theorem concept. Bayes theorem is very widely used, it has lot of applications in machine learning. Directly there is a naive Bayes classifier which is based on Bayes theorem, right. So, in this module we have studied about different probability concepts, we have seen about the sum rule, product rule, conditional probability as well as Bayes theorem, right. Thank you.